Hey guys, this video is on naming ionic compounds with polyatomic anions. What does that even mean? Polyatomic anions? Well, you're used to naming things that look like this, right? Or this, or even this. So, sodium chloride, calcium oxide, magnesium chloride. Well, polyatomic anions are the anions that have more than one type of atom. Even MgCl2, magnesium chloride, is not a polyatomic anion because it contains two copies of the same atom. A polyatomic anion might be something like NO3- or CO3 2-, nitrate and carbonate. Those are examples of polyatomic anions. So when you see a compound, and the compound looks like this, you would name that sodium oxide. But if you looked at the compound and you saw something like this, well, that's not just one type of nonmetal, that's two. And you name this in a fundamentally different way. This is where I have made a list of polyatomic anions for you on the back of your periodic table. So why don't you press pause and go ahead and get that. Now that you have the periodic table, you should see a column that has 1- and a whole bunch of polyatomic anions under it. Another column that says 2-, 3-, and a whole bunch of ions underneath it. There is actually one polyatomic cation. That's the ammonium ion. However, all the other ones on that on the back of your periodic table are negative. They're polyatomic anions. So when you look up NO3-, you should find it somewhere in the -1 column. And next to it is the word nitrate. So NaNO3 is nitrate. Sodium nitrate. When you look up at something like CaClO2, we see Ca, right, the metal part, calcium, but then you see chlorine and oxygen. So this is an indication that it's a polyatomic anion. You flip over to the back of your periodic table and you find it. When you find ClO2, it's ClO2-. So CaClO2 is, right, this whole thing is -1. And so the reason why there are two of them in calcium chlorite is because the calcium itself is 2 positive, right? So calcium chlorite is CaClO2. Calcium chlorite. Now, do I expect you to memorize chlorite, nitrate, and all the others on the back of the periodic table? No. You can use that as a resource for all of your tests. Let's try another one. How about K2SO4? We notice that it's an ionic compound made of a metal and then two nonmetals. We look up SO4 and we find it in the 2- column. So SO4 as a group, right, carries a charge of 2-, which is why potassium sulfate is K2SO4. K2SO4, potassium sulfate. It could get a little more complicated. When you see this compound, FeCO3, there's a level of complication there. Because unlike the previous examples that we just went over with Na, Mg, Ca, K, all of those are either in group 1 or 2. As you've learned in previous lessons, when you have a metal that's a transition element, you must name its charge. When we look up CO2 or CO3, we find that CO3 is in the 2- column, so that the entire CO3 carries a charge of 2-. We do not include the subscript here when considering the charge. All that we consider is this acting as a whole group. I look at the charge on that group. That whole group has a charge of 2-, which means that the one iron must be 2 positive. So this is iron 2 carbonate. Let's try another. When I look at this compound, I see it's ionic. It's made of a metal and several nonmetals. So when I name this compound, because it's made of multiple nonmetals, I look up on the back of my periodic table and I find SO3. SO3 carries a charge of 2-. How many SO3s are in this compound? Well, there's 2 of them. So when I look at the Pb, the lead, I have to figure out what charge it is. I can't just say lead and then the SO3 is sulfite, right? I can't just say lead sulfite because lead, of course, is a transition element, and so I need to put something in Roman numerals. Lead, in this case, must have a charge of, well, if my sulfate as a whole carries a -2 charge, and there's 2 of them, that means that one lead must be 4 positive. So this is lead 4 sulfite. Let's try another. When I see this compound, Cu3PO4, I notice that it's ionic, it's made of metal and nonmetal, but that the copper, the Cu, is not in group 1 or 2. So when I name this, the copper is going to have its charge specified in Roman numerals afterwards. And when I look up PO4, that's phosphate. What charge goes in there? Well, phosphate is in the 3- column. That means as a whole, this group carries a charge of 3-. How many coppers are there? Well, there are 3 of them, each of which has a +1 charge. How did I know that? The 3- must be balanced with 3 positives. If there are 3 coppers, each of them must have a +1 charge for a total of 3 positives. So this is copper 1 phosphate. Transition elements, as you know, can form multiple positives. When copper reacts, it could also actually form the 2 positive. So another possibility when copper and phosphate come together or react, copper, phosphorus, and oxygen, is copper in the +2 state. Now, if copper were in the +2 state, copper 2 phosphate would have a different ratio. It wouldn't be Cu3PO4. What would it be? Well, if the copper has a charge of 2+ and the phosphate as a group carries a charge of 3-, the least common multiple would be a 6. So it would be Cu3PO4 2. That would be copper 2 phosphate. Let's go backwards and name a few. What if I want to name tin 2 nitrite? Tin on the periodic table is Sn. 2 plus is its charge. I know that because the Roman numeral 2. I see it's nitrite, not nitride, so I look it up on the back of my periodic table, and nitrite is NO2 minus. The 2 plus and the minus 1 do not sum to 0. So therefore, I need 2 nitrites to balance out the tin's 2 positive. And as I always do, when I'm writing these ionic compounds, if I used the charges to help me balance, I would erase them in the end. Let's try one more. Iron 2 hypochlorite. Iron 2 hypochlorite. Fe is the symbol for iron. If it's 2 positive, I'll put that right there. How do I know it's 2 positive? Our Roman numeral 2. And then I look up the hypochlorite ion, ClO. And when I do, I find that it's in the minus 1 column. Iron 2 hypochlorite, therefore, must be FeClO2. And as always, I erase my positives and negative charges. That is how you name polyatomic anions that are inside. Well, that's how you name ionic compounds that are made of polyatomic anions.